In this next video, we will be going over practice 2 in activity 1. The skills we'll be working on is comprehending written cell ranges. So we've kind of already looked at how cells are referenced with a letter representing the column and a number representing a row. Okay. We're also going to search and use some Excel formulas and functions. Perform calculations with a fixed cell reference. So if you recall in practice 1, we created a calculation using a cell reference. What happens when we want that cell reference to stay the same, but we're copying in different directions? So that's what that fixed cell reference means. And then we're also going to practice organizing data and calculations in tables. Okay. This will be a particularly good skill for you guys to have. A lot of times in activities, I'll ask you to make calculations and then put those calculated values into a graph. Okay, and the way that you organize your data in a table will make the difference in how it comes out in your graph. So this is a good skill to build on, and we will keep practicing it as we go throughout this semester. Okay, so the first thing that we're going to do is go to the sheet labeled Practice 2. So you can navigate if you were previously on sheet number 1, which is where Practice 1 is. We can now go to sheet number 2, and you will see a bunch of data. Okay, if we use this little slidey bar, there is a lot of it. Okay, so this is a really great example that I like to use because there is a lot of data, and when you're working with really, really large spreadsheets and lots of numbers, it's nice to have an expedited way to make calculations. So just to give you a little bit of context on what is contained in this spreadsheet, we have 18 subjects who participated in a graded exercise test, right? During which their heart rate was recorded every 20 seconds for 20 minutes. Okay? Subjects were divided into groups of 6 based on a randomly assigned pedal rate. And we've got a low pedal rate, a normal pedal rate, and a high pedal rate. What those pedal rates actually are, we don't know. This is just the label that we've got. Okay? So the first thing we're going to do is just copy and paste looking at written cell ranges and understanding how to read, right? Because cell ranges are going to be implemented into different formulas that we use throughout the semester. So understanding how to read them and how to actually select them is important, right? So this first activity, we're going to copy cells A1 to C19. When you see a colon, that means 2, right? From point A to point B, okay? So we want A1 to C19. So if we go to our data sheet, and we're going to paste them at cell A22 just for reference. Okay, we can see A1, right? That's the cell that is highlighted, and we want to get all of the data from A1 to C19. So there are a couple ways we can choose to highlight this information. We can either use our cursor and select that range. Okay, we can also start at A1, press and hold the Shift key, and click to C19. That's another way. Whatever floats your boat. Okay. I'm going to copy this by pressing Command C, or if you're using a Windows computer, it'd be Control C. And then I'm going to paste it at cell A22. Okay, so column A, row 22. Control V to paste. And we now have the exact same data, or at least an outline of our data pasted below. Okay. The next thing we're going to do is copy D1 to BL1 and paste at cell D22. So we'll go back to the spreadsheet, and we can see column D, right? So D1 right here. So one way we can get to BL1 is by clicking and dragging, right? I don't personally like that method because sometimes we can get a little bit overzealous. We pull the cursor too far, and then before you know it, you have bypassed where your end range is by far. And then it's a matter of finding it. So a method that I like to use that we presented in the previous practice video is that we can choose the cell that we want, right? If you press and hold Shift Command and then press the right arrow on your keyboard, that will take us directly to the end of the data set. Super, super quickly, right? Another way we could do this is if we choose the cell we want to start at, and then we can use our scrolling bar to take us to the end, press and hold Shift, and then click on cell BL1. Okay, so either way works, whatever floats your boat, and then we can copy and paste that in cell D22. So now we've got kind of the skeleton of our data table and all of our time points copied a lot faster than if we had to manually input a bunch of stuff. Okay. So now what we're going to do in part B is we're going to normalize heart rate values using the maximum heart rate. Normalizing usually is referring to creating a level starting point for everybody in your sample. Okay, we know that maximum heart rate is going to change with age. So we can't assume that everyone's maximum heart rate is equivalent to somebody else's maximum heart rate. And thus, based on your maximum heart rate, your regular heart rate that shows up and how it increases or decreases with exercise is also going to be different, right? So what we can do is we can normalize or use a normalizing technique where we say this is a person's maximum, right? It could be their, maximal EMG output if we're measuring muscle activity. It could be their starting flexibility, and we want to normalize like what's the percent increase in flexibility that a person experiences from a particular stretching program. Okay, so if we use maximum heart rate and then we refer to the heart rate measured at each time point as a percentage of that maximum heart rate, then everybody technically starts at 0% and has a possible range of 0% to 100%. Okay, so the way that we're going to do this is we're going to start off in this cell, time point 0. Okay, we'll put an equal sign because we want to start a calculation. And creating a percentage is generally how I remember it is over of, right? So what is the value you're creating a percentage from? Of what is like the possible maximum, okay, or what's the whole, okay? And then we can multiply that by 100 to get it out of a decimal format, and we press enter. So we know that 124 is 65% of 190. Right? And that's for subject 1 in the low pedal rate. Now, if you recall, when we copy sideways, right, if I double click, this is just for an example, so don't do this, right? If I copy sideways, you'll notice that the cell reference for the time point changed to 20 seconds, which is what I want it to be. However, the heart rate max cell reference, this red box, you can see matches with the formula here, shifted to the right as well. And that's something that I don't want. Okay, so this is a great example of when we would want to use a fixed cell reference, right? Because we can see that this red box technically should be fixed on the heart rate max for this subject. Okay, so how do we do that? Okay. Also, just want to take the opportunity to show an example of when we copy downwards, right? Similar to the previous practice activity, when we copy down, you can see the references that started in this box and this box have both shifted down one cell. So we copy down one cell, the cell references shift down one cell. If we copy to the right, the cell references shift one cell to the right. Okay. So if we want to fix our heart rate max, right, what we can do is we can add a dollar sign. Dollar signs will fix cell references. The placement of the dollar sign is important though, okay? So the cell we want to fix is C23, right? So we're going to be focusing our attention on this red portion of the formula. If you place a dollar sign in front of the row, that will freeze the row. So if we were copying downwards, in this case, C23 would stay 23. That number wouldn't change. Columns would change, all good stuff, right? But the row itself wouldn't change because we put the dollar sign in front of the row reference. Since we're copying sideways, and we know that the column changes as we go to the right, we actually want the column to freeze. So in this case, we're going to put a dollar sign in front of the letter, which represents the column. Okay, so you want to freeze a column, you put the dollar sign in front of the letter. If you want to freeze a row, you put the dollar sign in front of the number. Okay, so let's test this out to see if it works. Right, we can copy our formula to the next cell at time point 20 or 20 seconds. And we can now see the time point shifted appropriately to the heart rate for this original data collection. And we're still comparing it to the maximum heart rate for the subject number 1. So we have successfully calculated a percentage that matches the appropriate time point, the appropriate heart rate max for the appropriate subject. So now all we have to do is copy this formula down all the way to BL, or time point 20. Don't click anywhere, okay? Because this is the cool part. From here, we can copy this downwards as well. So if we click and drag, I think, let's see, there are 18 people, so we would end up at row 41, I believe. One row too far, but that's okay. We can just shift it up. Okay, so now we've got all of our people accounted for. Look at that. Okay, and then if you want, I always make a personal habit of just checking some random cell to make sure that it is referencing the appropriate values. So if I double click on this cell here, right, I can see I'm at time point 1 minute and 40 seconds for subject 5 in the normal pedal rate. So if I scroll up to my original data set, I should be referencing the raw heart rate that was collected at 1 minute 40 seconds for subject 5 in the normal pedal rate. And I should be referencing their heart rate max, which I am. So that means our formula worked, right? So that using fixed cell references, you can see how quickly we just did all of those calculations in a very, very few steps. So instead of going in and manually entering each heart rate divided by that particular maximum, right, this is a much, much faster way of performing a lot of calculations at one time. Okay, now we're going to create a couple of tables where we can record the average heart rate attained for each protocol for each time point, and then we're also going to create a table where we can record the standard deviation for each protocol for each time point. Okay, so similar to kind of how we copied and pasted stuff before, the easiest way that we can format this is by identifying the protocol. Okay, so if we want average protocol or the average percent heart rate max for each protocol or pedal rate, we can identify our low pedal rate, normal pedal rate, high pedal rate, and then across this direction we can then take our time points. So similar to our previous copying experience, use the method in which is easiest for you to copy all of the time points. I'm choosing to line mine up just for ease of calculations. Okay, and this is going to be our average table, so I'm going to Oops, I'm going to type that over here just so we keep track of what's being calculated. Okay, I like color, so I'm going to make it yellow. And now we can calculate an average. Okay, there's a couple ways we could do this, right? We can either use our function icon, right? So we can click on that and then I can see average, right? And if I want to look at the information on how to insert or what the function actually does, there's a description as well as the syntax. So the general structure of an average function is you have the average function, and then in parentheses is what the function is encompassing. So if we want averages of number 1, number 2, and so on and so forth, we then get the average of all of those numeric values. So we could insert individual cells, right, if we wanted to calculate any random cell references in here, or the average of any random cell references. We could select a cell range. So it depends on what you're calculating. But this is one way to find a function, right, by using the insert function icon and then finding it either by typing it in the search bar or using your recently used functions. The other way is if you already know what the function is that you're going to be using, you can type equals and then start typing the function. So this is a good example of what I was explaining in the previous video, where you start typing and then you have a list of functions that include whatever text you have entered. Okay, so you can either click from this drop-down menu or you can just continue typing. You put a parentheses, and then we can choose the cell range that we want to calculate the average for. At time point 0, we want to calculate the average for the low pedal rate people. So that means we're only interested in these 6 cells. Okay, so I can stick in, you can see we have a range of D23 to D28, and I can press enter, and I now have the average for that area. Okay. From here, you can copy this function. Let's copy it downwards. Okay, but remember, if I'm copying from here to this cell, my references are going to shift down 1 row. And we can see that there are 6 subjects, right? So instead of being from 1 to 6, when I look at the normal pedal rate as copied right now, it should show up as subject 2 in the low pedal rate to subject 2 in the normal pedal rate. And we can check this by double clicking on the cell, and you can see the range that I just described is pretty much what is shown here. So what we can do is just drag, right? If you click on any of the borders, whenever the white hand pops up, that allows you to move the box around, right? It's important that you don't click on any of the square boxes in the corners, because that will resize the range and we don't want that. Okay, we just want to move the box so that we're encompassing all of the normal pedal rate subjects for time point 0. So we can then press enter, and then we can change the range for the high pedal rate to make sure that we have all 6 subjects in the high pedal rate at time point 0. Okay, from here, we want those same ranges, and we want the averages for each time point thereafter. So all we have to do is highlight those 3 calculations that we easily made, right? And then we just copy them all the way to time point 20. And now we have averages for each pedal rate for each time point for all of the subjects. Okay. We'll do a similar thing for standard deviation. So I'll just put SD to represent standard deviation. Okay. And we can make a similar setup. So I can copy my time points and my data labels. And let's search for what the standard deviation function is. So again, we can use the insert function icon, which I have standard deviation in my recent list. If you wanted to try searching, right, we can see STDEV, right, and it estimates standard deviation based on a sample. So you can see I started typing standard, right, and it's going to give you the closest match. So if you do one letter at a time, if you're searching, I feel like that might be the best method, and then you figure out what to use. You'll notice that there are several standard deviation calculations. Some of them are for samples, some are sample statistics, some are for population parameters. The STDEV, it's based on a sample, so technically these two are the same. But I like to use the STDEV. I don't know, it makes the most sense to me. So we can do equals STDEV, and that is pretty much the same process. We highlight the cells we want to calculate the standard deviation for. I want to change the cell format to 2 decimal places. Okay, and then I can click and drag and change the cell ranges so that they match the protocol that I'm interested in calculating the standard deviation for. And then from there, I can just copy my formulas all the way to time point 20. And now I have standard deviations calculated for each time point for each petal rate. Okay. So from here, you're going to answer questions in the answer sheet related to practice 2. This is a written format of how freezing works. So again, if you want to freeze a row, this goes over where to place the $sign. If you want to freeze a column, same thing. Okay. And I'll see you in practice 3 video.